Hello, everyone. My name is Ravi Mishra. I'm product manager for UCS X-Series. UCS X-Series is Cisco's new innovation in the UCS family. We reimagine the compute and compute fabric yet again. And in the next 45 minutes, I'll get into the detail of that how this new infrastructure is going to be the compute and cloud infrastructure for the next decade. But before that, we always start with the history lesson. We always learn from the history. And if I look back in the next decade, in the last decade, we launched UCS in 2009, right? It's been 12 years almost. And when we launched UCS 1.0, our goal was that how we can simplify IT infrastructure and operation. And we added a lot of hardware innovation around those lines. And I'm just going through a snapshot here that the first thing we did with UCS, converged network management and storage into one single fabric, and we call it Unified Fabric. Unified Fabric was the game changer. It was a disruptive technology. Why? Before UCS, every server needs 8 to 10 cable, and it was a complex environment of LAN, SAN, and management where you have to manage so many switches, so many cables, and everything. We virtualized the cable with Unified Fabric. It's completely simplified the operation. It also helps customer not to think about how many network interface card I need, how many HBAs I need, what kind of management interface I need. Completely simplified. We had Fabric concept, and with the virtualization of cable, you don't have to think about how many cables you need to connect. So in UCS, you always connect for bandwidth. You do not connect for functionality. The second thing we did is the software definition of a server, where with the concept of service profile, you are creating that server definition and putting it into a slot inside the chassis or putting it onto a server, which is defined by the computer architecture. And then if you look at the performance and resiliency, we always had the concept of active-active fabric, where you can easily do non-disruptive firmware upgrade or non-disruptive operation. We have the concept of end host mode, where you are using both the fabric at the same time. So we multiply the bandwidth almost double in any scenarios where you always have fabric A and fabric B. That give us almost 150 plus performance world record, because we also provided a best combination of compute, memory, and IO for enterprise application. And then we did the partnership with our storage partners, and we created the concept of converged infrastructure stack, FlexPod, Flash Stack, vBlock, VxBlock, and others. And we provided Cisco validated design to our customers so that our customer can deploy those applications with confidence, right? And last but not the least, power and cooling innovation. So think about in 2009, when we designed UCS 1.0, at that time, CPUs was in 55 to 65 watt range. Now with M6 server, which we just GA'd on this chassis, has 270 watt CPU. So think about the innovation you have to do and future proofing you have to do 12-year back for supporting an architecture of 2021 in 2009. We are leveraging the exact same innovations, and we are moving beyond and using all these innovative technology in UCS X-Series. The second thing is not only we stopped with the storage partnership, we did a partnership with all our enterprise applications. And as the first 5 years of UCS, we focused on virtualization, but the next 5 years of UCS was all focused on data intensive workload, hyper-converged workload. So that's why you're seeing that there is a combination of solution brief or Cisco validated design or providing the full stack solution, working with all these partners we provided to our customers so our customer can deploy these applications on our infrastructure. And number three, looking back in the last 10 years, the management aspect, right? When we launched UCS in 2009, life was very simple. We only had UCS Manager to manage UCS servers, right? But slowly for multi-domain management, UCS Central came in, and then UCS Director came in for managing infrastructure, and then IMC Supervisor for managing rack servers. So at one point of time, there was 4 options for managing UCS infrastructure for the customer. And the customer asked that, hey, I need to simplify this. So that's where Intersight was born, and just talk about Intersight in detail. But Intersight is the single management platform and also the operating model, which is based in the cloud. It's also on-prem, but it's going to simplify the infrastructure operation up to the next level for the cloud-like infrastructure. So why we need new product line now? What's changing? If you look at the complexity in the data center, this is the example of any data center, any customer data center. They have plethora of server, network, storage, hypervisor management, system management, everything. Why? Because the customer has to deploy multiple different applications, and every application has its own demand of resources. Some application needs GPUs, some application needs more CPUs, some application needs more storage. So depending upon that, customers are deploying these applications, and that's where they are introducing hyperconverged, local storage, object storage, fiber channel storage, internode communication for Ethernet, NAS, and infinite band, and on the server side, they have rack server, blade server, hybrid server, 1RU, 2RU, 4RU rack server. There are so many choices for the customer for deploying an application, and also they are deploying these, and every layer comes with its own management challenge. So there's already an integration challenge for the management, how you can manage your compute, network, and storage, but this orange box is complex. It's not agile. So think about if I'm an AI/ML user and I'm running a simulation. I have 2 GPUs in my server, and I need third GPU because today's Friday. I need to close my laptop. No one works from office these days, so I want to close my laptop and go back and do my things. But I cannot do that because my simulation is taking longer. I need one more GPU. So incremental scaling. I need one more GPU to finish my work faster. But the challenge in this case, even if I go to my IT and ask for more resources, they will ask that I can only give you one more same thing. I cannot just give you incremental resource, what you're looking at. I can give you one server that will come with 2 more CPUs, 32 more DIMMs, and 2 more power supply and 8 more cables if it is non-UCS, and it's going to take a couple of weeks. Then only you will get that resource. But this user was looking for a resource, which is called GPU in this case, on demand for only for the weekend so that he can give it back on Monday. So there is no such concept. Even if the IT has some resource available in, let's say, in his database rack, they cannot share this with this virtualization rack because the servers are completely different. The requirements are completely different in this case. So there is no agility in this case, right? You have duplicates of resources at multiple places, at multiple rack location, and it's keep lying. You cannot even share your resources, whether it's a server or it's network or it's storage. So it's completely inefficient. Our goal is to simplify this. Our goal is to simplify this orange box and provide customer a box where they don't have to think about the same way we simplified their decision for network management and storage with unified fabric. With UCS X-Series, we want to simplify this decision where if the customer is deploying an application, which they are deploying today in the blade server, or they are deploying in the rack server, or they are even buying a spatial purpose built server, they can deploy that application in one single box, and they don't have to spend time in thinking about what I need for this application. If you also look at the next 4 or 5 years, the innovation which we know it's coming in the industry, most of these innovations are disruptive. They are going to change your data center design. They're almost forcing all the vendors to rethink their system design. Think about high voltage CPUs and the GPUs. CPUs are already going to 300 plus watt. GPUs are already at 400 watt. They are putting so much stress on the power envelope and the energy consumption of any infrastructure. So if you're designing an infrastructure, you need to think about that, how you can support these requirements. PCI, from the last 15 years, PCI Gen 3 is there, and suddenly we're talking about PCI Gen 4, Gen 5, Gen 6. So if you are designing a system based on a particular interconnect technology, you need to make sure that it can support the upcoming disruption, like CXL in this case, Compute Express Link, which is the interconnect, which is the technology going to be based on PCI Gen 5. So all these are examples where customers are already asking that how the next-gen infrastructure can support this innovation coming in the industry. Ethernet fabric is getting stressed more because there are internode communication and NVMe over fabric. There are multiple technologies which are adding more traffic over the Ethernet fabric. So when we launched UCS in 2009, multiple 1 gig was popular in the data center. We launched UCS with 10 gig. And now we are seeing the demand of 100 gig inside the server. We are also seeing the demand of maybe 400 gig in future. Who knows? Because these applications are stressing the Ethernet fabric, because also the customers are putting more VMs, more containers on one single server, because the single server has more cores, more memory, and more network to support that, right? So these are challenges we see for the innovation. And then on the definition of an ideal modern hybrid cloud infrastructure, right? Most of the time you think about that underlying hypervisor, underlying container, or management software will provide the abstraction, and I don't have to worry about the infrastructure. But that's not correct. If as a customer you want to run any application, any workload with any hypervisor, you need the infrastructure which can adapt to that environment. That third GPU that user was looking for, you need the infrastructure which can add those resources whenever application demands that. So we fundamentally believe that the modern hybrid cloud infrastructure has to be an end-to-end architecture. That infrastructure needs to work with the operating model. In this case, the Intersight management services. It has to work with that. You need to design with that in mind, and you need to develop that in the mind. So what we have as a solution is, as Justin talked about, Intersight services. Intersight provide the services for the management. It provide the services for your operating model. It's not only the management, it's the operating experience, which completely simplify your management. It provide observability. It also provide agility. But the underlying infrastructure in this case, UCS X-Series, provides their compute and compute fabric, which is completely agile in this case, right? You have the option of turning this into a blade server, turning this into a rack server, turning this into a spatial purpose build server. That's why we call it X. X is the most common variable on Earth. X also means 10. So this is the technology for next decade. This is technology which can, take any shapes depending upon what's going to happen in the next 10 years. This is technology for 2031, which we designed in 2021. Okay. Let's take a deep dive into the X-Series infrastructure and see what we have here. So this is a 7RU chassis. It has all the benefit of existing 5108 blade chassis. That's why I shared some of those information that what we did 12 years back with UCS 1.0. It has all the benefit. It's actually built upon those innovation. All the concept of unified fabric, profiles, policy, statelessness, where you can move your server profile from one server to another. The management is completely simple. It's based on Intersight management only, which has SaaS and on-prem flavor. And then we are also adding a concept of node here. So these slots in the front, as you're seeing, they are compute nodes. In future, you will have multiple different types of node in the front, where if you need more GPU, you can add GPU node. If you need more storage, you can add the drive node. So those are the disaggregated approach we are taking here, where based on what application need, the customer can easily able to provide those application the resources. And in this case, if you look at the unified fabric is still there, but we increase the bandwidth of unified fabric for the application of next decade. So that's where 1600 gig inside the chassis and 400 gig upstream with 25 gig infrastructure. With 100 gig infrastructure, it will be 1600 up and 1600 down. So that's where the kind of changes are coming in the bandwidth, where there is no backplane in this case, first of all. So there is no limitation that if today I'm supporting a 10 gig or 40 gig Ethernet or 25 gig Ethernet, this infrastructure can support the Ethernet technology of next decade, right? And I'll get into the detail of that how it's look like. And then we are bringing a complete new fabric called UCS X-Fabric. X-Fabric, again, X means that this fabric can take any shape and size, depending upon the technology. We will start with PCI Gen 4 for connecting the compute node to these different disaggregated node. But in future, when CXL comes, this UCS X-Fabric is going to support CXL interconnect and is completely backplane-less inside the chassis, low latency, high bandwidth fabric. And that's where there will be different nodes in future for connecting through the X-Fabric. This is the more detail of the chassis. This is, I mean, can you go more simpler than this? There is nothing inside. It's completely backplane-less. On the right side, you have 6 2800 watt power supplies, 2800 watt, right? So that's where this chassis can go 14 kilowatt kind of like power, so that you can easily enable 400, 350 watt CPUs and the GPUs of future. And then if you look at that's where we are focusing on only putting the compute, memory, and I/O inside the chassis, so that there is no limitation that I cannot have those kind of CPUs, GPU, and the resources in future. If you add 8 compute nodes, just like today in our 5108 chassis, 8 B200M6 server, we are talking about 600 plus cores, 100 terabyte of memory, more than 1 petabyte of storage in 7 RU. So still going to provide the densest platform, all the benefit of the blade, where you're optimizing in a 7RU platform, simplification with the unified fabric technology, but providing you much more option of doing more with less. This is the back view of the chassis, where in the back there are modules, and the top 2 modules are intelligent fabric module. That's our Ethernet-based IFM, we call IFM, which will be used for connecting to Fabric Interconnect and possibly in future to other options on the network side. The bottom 2 modules are the UCS X-Fabric module, which will be based on PCI Gen 4. And then if you look at the modularity of the concept here, that you can easily take this module out of the chassis and put another module, like in this case, let's say you have 25 gig IFM now. In future, when we come up with 100 gig IFM, you are just putting that 100 gig IFM into the chassis, and now your chassis is 100 gig capable. So that's how the upgradability is. You do not have to make any changes, any design in the chassis to support the next gen technology, whether it's technology of Ethernet or PCI for the interconnect. It's completely modular. You can just replace those fabric. So we are following that Lego kind of design where you are putting. Yeah, go ahead, please.
Question. Can I replace those modules while it's productive?
Replace the module. Can you repeat again? Sorry, I missed that point.
Can I replace those modules while the system is up running and fully productive?
Yes. So as we always had in UCS the concept of Fabric A and Fabric B. So on the network side, because it's active fabric, you should be able to replace it. But on the PCI side, system behaves differently, right? On the PCI side, if you replace the PCI module, the PCI I/O may not be able to provide the hot swap support for the GPU. That's still work in progress. But yes, the expectation is that it will be non-disruptive upgrades.
Thank you.
And if you look at the module in the back, every module in the back has 8 connectors, and every compute node in the front has 4 connectors for 4 module. So there is no backplane. We are connecting these two together, like horizontal and the vertical, and that's how it's 4x8 matrix. So tomorrow, if you need 400 gig inside the chassis, you need 400 gig Ethernet module and 400 gig WIC into the server. Now your chassis is 400 gig capable. Think about, we are talking 2031, maybe 400 gig, maybe a very common bandwidth at that time. This is already ready for that technology.
I'm sorry. So when you talk about all these, all the things that are in the chassis, you can dynamically reconfigure these things and reassign the I/O and the GPU and so on to different cores at different times. Is that where we're going with this?
So that's our goal, Steve, because that's where we want to go. But the problem is that there are a few things which are not supported by the industry, by the technology right now. GPU hot insertion and hot plug, for example, right? You cannot online unload the driver or load the driver. So those are the things we are working with our partners, NVIDIA and Intel. But you will see those happening because in UCS, if you remember, we have that concept from day one on the network side where you can create VNICs, you can create VHPAs, and you can assign those based on the profiles and policies and templates. In UCS, we always had the concept of pools, resource pools, but we use those resource pools for network and storage construct. Now we are extending those definitions to the other kind of resources. And that's where you will see storage pool, memory pool, and the GPU pool in the future.
Yeah, that's going to be really exciting because then you kind of deliver on the promise of composability when you can really, basically construct the server you want at any time, right?
Exactly. Now you are no longer confined to a single slot inside the chassis. Now you are truly defining that software definition of a server from the concept of profile, but it lives beyond that single slot inside the chassis. Yes.
Ravi, sorry. I totally get, the story about the future, but I have two concerns here. If I have VMware, I can do this already. VMware has a GPU virtualization technology. They bought the company a couple of years ago, 3 years ago, and then implemented it in VMware. So actually, I already have the possibility to, let's say, compose my infrastructure easily if I need it. So I can, for example, use GPUs for VDI during the day and reorganize GPUs during the night to do some ML training or whatever. And so it's there. And the other thing is, yes, you have a new chassis, but today it's like the old chassis, just faster, probably, more powerful, more everything, like the next iPhone. It could be better than the older one, but there is no, nothing that I can see here. And then I don't want to steer any polemics here. There is nothing really innovative or cloudy or, or composable or anything. It's a new chassis.
I can definitely answer that. So your question on the VMware and the Bitfusion IO, for example, their acquisition where you can have NVIDIA SMI command and you can get a GPU attached to a particular VM or a particular workload, right? In that case, the abstraction layer is that the hypervisor, right? So let's say you have one rack server. In that rack server, there are 2 GPUs available, right? And then you install ESXi on top of it. Then you install Bitfusion software. Then you install NVIDIA command. And then now you are presenting those 2 GPU in your provider pool. Going up to that level itself, there are so much uplift you have to do. You have to automate all these, you have to install all these. And then on the hardware level, there is no incremental resource pool in this case. You have 2 GPUs. Those are the only 2 GPU will be available for you. If you want third GPU, you need to get one more node. You need to add one more ESXi node. You need to again provision that node the exact same way, installing the Bitfusion software, installing NVIDIA software, everything. What we are presenting, the exact same concept in the hardware itself. When we launched UCS 1.0, we did hardware vMotion. In case of VMware, it was vMotion only after installing hypervisor. In our case, vMotion at the layer 1 in the hardware itself, where I can take a service profile from slot 1 and put it into slot 2. If I'm getting a new, it's almost like a SIM card inside the iPhone. It's not the iPhone I'm talking about, which you are getting that concept where you can easily do the same thing at the hardware level. Because remember, there are applications which may not be virtualized, which needs container could be on bare metal, container could be on virtualization. So because in data center today, you are looking at all these plethora of hardware for the different application needs, we think that the way in UCS, we did that with the stateless model at the hardware level, we are bringing the same concept in the hardware itself, where I need more GPU, I will insert a GPU node inside my chassis, and now I got 4 more GPU at the PCI level.
But you don't have it today. When CXL will be available, it will be available for everybody. Every single vendor in this world, and everybody will have this technology, and they will have an implementation at the time. If I want it today, the only way I can do it with your technology and any other technology in the market is with with VMware, or maybe with Liquid if I want to use a product from a startup. But there are not many other options. I mean,
no, I will show you, and I have a slide actually. We are doing it right now with this chassis. That's the reason I think
so you can do it right now. Okay.
Until this point. But yes, yeah, I have a slide talking about the X-Fabric. That's where the X-Fabric come into the picture. That connects today on the PCI Gen 4 compute node with the GPU node. You don't need to wait for CXL for that.
Okay. So I have a question. What does the management? Yeah, what's doing the management for this, right? Because we just heard a presentation that said there was not a way to repay. So if I'm looking from the application level down, what's actually great? I can throw another GPU in there and it's recognized by the system. What's the management system for the UCS system? And then how does that go back up? So like if I say, oh my gosh, I want to use I think the VDI by day, compute by night's a great example. I want to be able to take all this VDI power and use it for compute at night, and I have all these GPUs. I want to repave and do this. It's like, if you can't repave, how are you actually being able to take advantage of reconstructing the actual infrastructure, the physical layer, whenever you need to? How's that working?
Yeah, so that's where Intersight is the management for this infrastructure. Justin was talking about all the Intersight services. Intersight and UCS has always had the concept of profiles, where if I need, let's say, AIML profile to run my AIML workload in the day, I will attach that profile when I come into office at 8 a.m. and I attach the profile. Now I'm using that for my AML application. I'm going home at 5 a.m. and 5 p.m. actually, and then I'm attaching the profile for another application like backup application, for example, which is going to run during the night. So UCS had that concept from day one. We are going to leverage the same concept. In this case, the management will be Intersight, not UCS Manager, but Intersight provides that one single view of profiles, policies, and templates where you can even run multiple different templates based on the time of the day.
Okay, I'm having a hard time seeing it based on the fact that you guys can't repay. Yeah. I'm just having a hard time understanding how you're able to reuse the hardware.
So on the power and cooling side, in the interest of time, let me get into some of the innovation on the power and cooling side. As I mentioned, 2800 watt power supply, but that's not enough. Just powering on is not enough. We made a decision, which is not in the industry today. Generally, industry standard is 12 volt right now. We made a decision to go with 54 volt DC distribution inside the chassis. And if you remember, if the voltage is high, current will be low. If the current is low, I square R, your college days, calculation for heat, right? So heat dissipation will be low in this case. So this chassis has lower cooling requirement as compared to the chassis of existing industry, including our own chassis, because that's where we need to think about that, how we can design the infrastructure for the next decade, right? And in this case, we also have sensors. The chassis has a concept of sections and the zones. So let's say if there is a particular slot which has higher CPU or a GPU inside, that slot will get more cooling as compared to another slot which may have 100 watt CPU, for example, right? So those are some of the intelligent decisions our management platform is going to make to provide efficient cooling. First of all, cooling requirement is already lower, but if you need more cooling for the resources, that's what's going to provide more cooling for that. In the interest of time, let me talk about the X-Fabric technology, which you're asking about. So this is the technology where we are going to connect your compute node with the storage node, with the accelerator node, whether it's GPU or FPGAs in future, and possibly memory. So yes, for memory, you have to wait for CXL because I think that's where the industry is going for. But everything else like accelerator and storage could be easily possible over PCI Gen 4. So we are going to come up with the GPU node and the drive node on this, where you can add those resources for your applications. And our goal here is that you should not rip and replace. I mean, the whole concept of profiles and policy in this case, that Intersight should be able to provide those policies, those GPU profiles or whatever we call it, to your application, just like you are changing an instance of a cloud, right? So you're by adding a particular resource. So the whole concept we have today, where I can add more VNICs by just adding a VNIC template into my profile and creating more VNICs out of it, you will have very similar concept where Intersight is going to add those resources based on the profiles. And also the X-Fabric itself is X. I mean, it's a variable. So IT, they don't have to think about that. If in future, if anything else will come, PCI Gen 6, we should be able to support that in this very easily. So here, as I was mentioning, Steve, the deploying an application is no longer limited to a particular single slot inside the chassis, right? If I have AI/ML application or VDI or big data, which needs more storage, I mean, definitely the big data application needs a lot of storage, right? Because it's a data. And VDI needs faster compute and a faster GPU. AI/ML definitely need more GPU. So that's where I'm defining that server definition now beyond the single slot into the multiple slot, and that will be the server in this case. This is the compute node, which is the hardware for our M6 base platform. This is based on Ice Lake CPU, Intel Ice Lake CPU, dual socket, 32 DIMM. It has the option of 6 drives in the front. Those drives can be connected to a RAID controller if you want RAID, or it can be NVMe pass-through directly to the CPU with PCI Gen 4 by 4 lanes. So that's where these 26 drive and 24 PCI Gen 4 lanes coming into the front mesh is going to provide you millions of IOPS. And we not only have modularity inside the chassis, we even have modularity inside the server itself. So the front mesh is completely modular. If you do not need storage, you want to connect to the fiber channel storage or anything else, you do not have to buy that. There are 2 M.2 NVMe drive inside the server for your boot option. In the back, there is a dual WIC option. If you want second WIC for connecting for higher bandwidth, or you want that WIC for availability, that option is there. The second WIC will also connect to the X-Fabric. That's where the PCI Gen 4 connectivity will go to those 2 fabric. So this is the kind of like a topology where, I mean, to understand where it all fits, right? So the connectivity is very similar to what you have today, 4-gen fabric interconnect. It's only going to support 4-gen fabric interconnect. And then those are going to connect to IFM, Intelligent Fabric Module. Those IFM goes inside the chassis. And the connectivity, as you can see, between FI and IFM is 25 gig. So you would be thinking that why you are going back to 25 gig from 40 gig. You have 40 gig today, and you mentioned 100 gig. But what we did in this case is increase the bandwidth by at least by 2.5 times at a minimum level. How? Because there is no backplane in this case, right? So this is IFM. This IFM has 8 connectors for 8 compute node or different nodes, and 4 25 gig going upstream. So 100 gig going up, and 200 gig going up, 8 25 gig, and 32 25 gig going down. So if you think about the VIC card, which is the virtual interface card, which goes inside all our server, UCS server, these VIC card will connect to the IFM. And those 2 connector, as you are seeing on the top, connects to the first 2 IFM, and the bottom 2 connector connects to X-Fabric. But there is a bridge which goes along that and connect the second connector also into the Intelligent Fabric module. And how it all brings it together, let me explain you that this is the bandwidth you are seeing today in our server with one single VIC with 25 gig infrastructure. You are seeing 20 gig VM NIC inside the ESXi, right? Because that's where the 1440 is. If I need to increase my bandwidth to 40 gig, there is a pass-through card which you connect, and then you will see 40 gig. In UCS X-Series, you will see 50 gig bandwidth, because remember, those IFM 25 gig is providing 2 25 gig connectivity on A side and 2 on B side. So you have minimum 100 gig bandwidth at one single compute level. You will see 50 gig on your ESXi the moment you're putting this card, and you can create as many as VNICs you want. You can create as many as HBAs you want. That's where our whole unified fabric technology works into the picture. So in short, if I want to move from 50 gig to 100 gig to 200 gig, what do you need? You do not need anything. You just need that profile definition change. For 200 gig, you do need second VIC because that's where we are adding more bandwidth. But for 100 gig and 50 gig, you create one VNIC, you will get 50 gig. You create two VNIC and attach to both fabric, you will get 100 gig. So think about the upgradability for any application. Today, it's rip and replace. If I need 100 gig in my server, I need to replace the network card inside my server. If I need 200 gig in my server, I need to add more cards, right? Or if I need to add more cables. In this case, nothing. You are with programmability, with your policy, you are changing the VNIC template or VNIC policy, and you are upgrading your bandwidth. So think about the upgradability concept, all from the software in this case. Okay. On the storage side, these are the options we will have. As I mentioned earlier, 6 drive inside the chassis. It can go either 6 NVMe. With 15 terabyte, you're talking about 90 terabyte storage per node. So that's where our calculation is that we are also looking into 30 terabyte NVMe. So a capacity of the NVMe is actually getting higher, and also, I mean, it's coming as more cheaper. So almost 200 terabyte of NVMe storage on one single compute node. Right, and that's where you have 3 options: whether you buy the controller, you buy RAID controller, or you buy NVMe pass-through. But this will give us an option to add more and more workload into this form factor, whether that workload needs local storage, whether that workloads need NVMe storage for the tiered caching. You can easily have that option. Today, in our Blade server, we do not have this level of storage, and that's where the comparison is. This is the comparison of our Blade server with the X-Series compute node. As you can see easily, on the RAID side, we support all kinds of RAID. On the storage side, with 15 terabyte NVMe, we are supporting 93 terabyte. On the I/O throughput today, it's 80 gig, it's 200 gig now per compute node, and then most of these workload, which we are only qualifying on the Blade, we can easily qualify on this form factor. But if you look at on the right side, that's where the difference is coming into the picture, right? The right side, the customers are today buying typically a rack server, or they're buying a special purpose build server. Those workloads can also be easily deployed on this form factor, because these workloads either need a local storage or they need the GPU for their application. So applications like big data, hyperconverged, archival, AI, ML, backup and recovery like Cohesity, we are going to qualify those applications in this form factor. So this is how, if the customer wants to deploy any application, whether it's high compute, high storage, high memory, high network bandwidth, they should be easily able to deploy in this form factor. They don't have to make a decision that I need a Blade server, I need a rack server, I need a special purpose build server for this particular application, and now I need to manage these 3 different kind of server with 3 different ways. I need to connect different ways. I have so many cables in the rack server. Every power supply needs cable. So those are the things we are simplifying in this case. Okay, this will be also part of a FlexPod and Flash stack, which is our converged infrastructure stack. We already announced it, so we are working with these partners, and we already provided some white papers on Cisco.com that if customer wants to deploy this as part of their FlexPod and Flash stack infrastructure, converged infrastructure, they can easily deploy the UCS X-Series and even get the benefit of more resources available.
So many other companies are talking about next generation PCIe drive form factors. And you mentioned M.2, which I suppose is probably U.2. Are you guys going to be doing some of the next generation storage form factors in order to, on the front of this, in order to increase density and cooling and power of drives?
Yes, definitely, Steve. We are looking into that. I mean, whether it's at EDSFF, whether it's a U.2, U.3, those are the technology, Event.s and E3.s, right? But the industry has not been mainly on the, not on the hyperscaler side. Hyperscaler side, they're using Event.s for the purpose of density. But we look into capacity, we look into the density and also performance, right? So these are the 3 criteria we have, and that's where we are exploring those options. And yes, we will support, because as I mentioned, this chassis can easily support PCI Gen 5 when the PCI Gen 5 will come next year. So yes, we'll have support for those drives. And I forgot to talk about the liquid cooling and silicon photonic. Those are the things which we do not see coming very soon in the enterprise data center, but it will eventually come with 400-watt CPUs and the GPUs in future. This chassis is already liquid cooling ready, whether it's open loop or closed loop. We have to see where the industry is going, but we already designed the chassis in a way that it can support the liquid cooling for those compute and the GPU infrastructure in future. Yep.
Are there any plates for some AMD-based plate? So those AMD Ryzen CPUs?
So right now on our M6 platform, in this form factor, we have Intel CPUs, but on our rack server, we introduce AMD. So definitely we will look into those as the industry is going into the different vendor option for some application. But yes, we are exploring those options also.
Thank you.
So our messaging is here very simple. Yeah, Nathan, sorry, go ahead.
No, I just had two quick questions. Well, hopefully quick. One was basically from a lot of chatter in Twitter. We're seeing a lot of differentiation between this and Outpost or Azure Stack. If we're looking at these as viable competitors, or are they competitors? What does this grant a user outside of bringing an Outpost in order to handle those type of compute modules?
So if you look at Outpost and Azure Stack and all, those are based on the operating model architecture, right? They have the cloud-based operation and there is an abstraction based on the software, but the underlying hardware do not have any of those intelligence I was talking about or hooks I was talking about, right? It's self-sufficient, kind of like a purpose built for that particular operating model. In this case, what we are building is an infrastructure which can be completely disaggregated, which can be easily managed either on-prem or SaaS-based with Intersight, right? And this gives you the enterprise deployment capability because you are using, customers are using these servers and the management model today. It's very easy for them to migrate into that with the additional resources providing. So to your question on Outpost versus Amazon, definitely those are some of the options customer has on a particular cloud-based vendor, but this is the general purpose enterprise architecture for deploying your applications on-prem, right? Because there are on-prem requirements for your application for the resources. As I mentioned earlier, the third GPU problem with that user on-prem, it's very difficult today. You cannot just add the resource. You have to wait for multiple weeks sometime just to get one more server and give that poor guy one more GPU. So that's where we are heading into. Most of our competitor, they have to redesign their architecture. We are at a point where we can see the future a little bit that where we are heading. PCI Gen 5, Gen 6, CXL, GPUs, we're at a point where we made the decision to design the architecture for next decade. But yes, they have to think through for architecture for the next decade.
I'm glad you brought up a waiting list for getting Outposts. We are now seeing a global chip shortage. Are y'all currently being affected by the waiting list for things like compute modules on UCS?
So, definitely that's the power of Cisco and the supply chain we managed through. So I don't anticipate all those, but it's a industry-wide phenomena. So I don't have the answer. But yeah, I think we are in a better shape, I would say.